Okay, so have you ever been to a construction site and seen one of these cranes and wondered, why do they have these slabs hanging from their rear? Well, welcome to the world of moments which will imbue us with the knowledge to understand what's going on here. Okay, so turning effects. In this topic, we will be studying two things. Number one, moments multi-pivot, and two, couples. Now, I want you to know that this topic is rather straightforward. All you need to know is how to resolve forces and the formula, which is quite simple honestly. With that being said, let's begin with moments. Here's an illustration. We have a plank with weights on both ends balanced over a pivot. As we increase the mass on the right side, the plank is bound to tilt downwards towards the right, and if we increase the mass on the left end of the plank, then it is bound to rotate downwards left. This is in large the result of the weight exerted by the mass, which acts as a downward force, pulling the plank towards the earth. Therefore, from this illustration, we can derive the formula that moment is equal to force multiplied by the distance from the pivot, whilst a couple consists of two forces equal in magnitude, also known as the quantity, meaning if the anti-clockwise force is 5 newtons, then the clockwise force will be 5 newtons. From this, we can derive that torque of a couple is the product of one of the forces, and the perpendicular distance from between the forces, also known as the diameter, giving it a formula of torque of a couple, is equal to force multiplied by diameter or distance. And that is all there is to this topic. All you need to know is the formula and how to resolve forces. So, with that being said, let's start working some past paper questions. Okay, so let's start by working some past paper questions. State what is meant by the term center of gravity of an object. Well, imagine we have a sheet of paper and you need to balance this sheet using your index finger. You would normally place your finger at the center of this sheet of paper, and that's the center of gravity because all the weight of this piece of paper is said to act at the center of the sheet. Therefore, center of gravity is the point where all the weight of an object is taken to act. Okay, so now we have what seems to be a beam that's supported on a wall by a string or a wire. And we need to calculate the vertical component. So we need to resolve this into its two components, which will give us a horizontal component and a vertical component. Great. So we know that the angle here is 37 degrees. So when resolving, we will be getting 45 sine theta on our vertical axis and 45 cos theta on our x-axis or the horizontal component. So the vertical component is going to be 45 sine theta, which is 45 sine 37 degrees, is equal to 27 newtons. There. Now we need to calculate weight W, aka the weight of this block, by using moments. So we know that clockwise moments is equal to anti-clockwise moments. I know what is going on here. And we know that the formula for moment is moment times force times distance. So we need to identify which are the forces that are going to be our clockwise moments and our anti-clockwise moments. So just going to change the size of this pen. There. We have a vertical force acting this way, which is going to be 45 sine theta. So 45 sine theta, or 27 newtons, is going to be our clockwise moment, and W and 23 newtons are going to be our anti-clockwise moment. Obviously, they're all technically clockwise, but when writing the equation, it's nice to consider them as one clockwise and one anti-clockwise, since they occur in the opposite direction. So let's go clockwise. We have 27 times the distance from the pivot. Our pivot is here. So the distance is 0.56 times 0.56. 6, not 7. 6 is equal to W times the distance, so that would be 0.56 plus 0.2. That would be 0.76. So 0.76 bracket plus 23 times, so the midpoint of this rod, because 23 is the weight of this rod, so it's all acting at the center. So we need to find the total length of the rod and find the midpoint. So 0.56 plus 0.20, that would be 0.96 divided by 2, and that would be, so 0.48. Therefore, 1516 is equal to 0.76 W plus 1104, which means W is going to be 5.368, which can be rounded off to just 5. So our weight is 5 newtons. Moving on to the next question, we need to find the horizontal component. Our horizontal component is simply just going to be this. So 45 cos theta. 45 cos theta is going to be 45 cos 37 degrees is equal to 35.9, which can be rounded off to 36 newtons. There. Now, we are going to be skipping these two questions because they are on elasticity, or basically material science, which I will be exploring in another video, perhaps the upcoming video from this one. So we're just going to be skipping this one for now. So, second question, state the principle of moments. The sum of clockwise moments is supposed to equal to the sum of anti-clockwise moments. So, sum of clockwise moment is equal to the sum there. Okay, so now we have sum diagram. Okay, so we have to calculate the moment for sphere P using the weight. We know that the weight is acting downwards, and our weight has a value of 0.3 newtons. Okay, and we need to resolve this. So we have our bar, which is 0.29 meters. Resolving it gives us a vertical component and a horizontal component. Our horizontal component is going to be 0.29 cos theta, 0.29 sine theta. So now we need to find the moment we know that moment is equal to force times the distance. Our force is 0.30 times our distance, which is also going to be our horizontal distance or our horizontal component. So 0.29 cos 40 is equal to 0.067. 0.067. The reason why we need to resolve horizontally is because the rod is at equilibrium, but not horizontally. It has an inclination, therefore we need to factor in the angle when calculating the moment. Okay, just moving on to the next question. Okay, so third question. State what is meant by center of gravity of an object is the point where all the weight of an object is taken to act. Okay, so now we need to calculate F by using moments. So we're just going to write our handy dandy formula. So clockwise is equal to anti-clockwise. Moment is equal to force times distance from the pivot. Now, we need to identify which are the forces that are acting in the clockwise direction and the anti-clockwise direction. So, clockwise, we now are going to be starting with 3 newtons. So, 3 newtons times the distance from the pivot, which is going to be 4 minus 1.10, and that's going to give us 2.90. 2.90 plus 44, and the distance from the pivot is going to be 1.70 minus 1.1, and that is going to be 0.60. 60 is equal to F times the distance from the pivot, which is simply 110. Therefore, F is equal to 31.909, which gives us 32 newtons. Also, you need to always round your answers to reflect the input values. So our weight, so I want you to pay attention to the weights. They have all been recorded to significant figures. Calculate the force exerted on the rod by the pivot. Okay, so I'm just going to clean this up first. Force F is 32 newtons. Now, all these forces, 32 newtons, 44 newtons, 3 newtons, they are all acting on the pivot. They all exerting a certain amount of force on the pivot P so that they can balance the rod. And that's going to be your answer for the second part. Force is going to be the sum of all of these weights. So 32 plus 44 plus 3 is equal to 79 newtons. Okay, so the last question. So the weight of this rod is 96 newtons at an angle of 38, so it's just basically downwards. We need to calculate the component of the weight that's perpendicular to the plank. So what this means is it needs to be perpendicular perpendicular means 90 degrees. That's what perpendicular means. So, in other words, we need to calculate the vertical component. I'm just going to draw the diagram here over again for conveniency. So, this is 96 newtons. Our vertical component is going to be this direction, and our horizontal component is going to be, in this direction, and in the diagram is going to be in this direction as well. So our vertical component is going to be 96 sine theta, and our horizontal component is going to be 96 cos theta. So the answer is going to be 96 sine 38 is equal to 59.1, which is equal to 59 newtons, shown. Right, so now we need to calculate the tension in the string by using moments. So our handy-dandy formula, so clockwise is equal to anti-clockwise, moments is equal to force times distance, and now we need to identify our clockwise and anti-clockwise forces. So we have a force acting in this direction, which is going to be 59 newtons. And we are simply going to ignore the original force. This, for all intents and purposes, does not exist. Right, so 45. This is going to be our clockwise, 59 is going to be our anti-clockwise, and tension, our anti-clockwise. Right, so now we can start plugging things. Clockwise, 45 times distance from the pivot A is going to be the sum of all these distances. So 2.90 is equal to 59 times the distance from the pivot, which is just 150, plus tension. Tension is just going to be 0.30 plus 150, and that's just going to be times 1.8. Now this is going to be 130 plus 0.5, 88.5 plus 1.8 T. Therefore, tension is going to be 23.3. And now, rounding it off, we are going to get just 23 because all the forces are recorded in just two significant figures. Okay, so that's about it. And thank you for watching my video. Bye-bye.